Hi, I'm going to do problem number 19 on page 436. This is in the hypothesis test section where we're testing claims about proportions. So this one says, trials in an experiment with a polygraph included 98 results. They include 24 cases of wrong results and 74 cases of correct results. Use a 0.05 significance level to test the claim that such polygraph results are correct less than 80% of the time. So based on these results, should polygraph tests be prohibited as evidence in trials? Okay. So we're doing a hypothesis test here. These are our results. So a couple things here. N is equal to 98. And p hat, the sample proportion. And we're interested in the proportion that are correct. So this would be 74 over 98. If you wanted, you could round this up to 4 places. So 7551. That. Okay, so to actually do the hypothesis test, we'll start out with our hypotheses. So remember, the null, we always want to have equality. So here we're testing about a true proportion. We want to know if the true proportion is less than 0.8. So we have equality in the null, so p is equal to 0.8 would go here. And remember, when you're doing a hypothesis test, whatever it is you're trying to test, the researcher's claim usually goes here. And here we're trying to test whether the true proportion of times it's correct is less than 0.8. Okay? So those are our hypotheses. The test statistic, and remember, one thing I didn't do here is when you're doing this particular test, you always should check whether P and N times Q are both bigger than 5 is kind of the usual cutoff. So here N is 98, and P is the hypothesized value, which is 0.8. And N times Q, so this would be 98 times 0.2. And you multiply those both out, but 20% of 98 and 80% of 98 are both bigger than 5, so we're okay in terms of our assumptions. So the test statistic, this is going to be a z-test. So z is equal to the sample proportions at 0.7551 minus the claim proportion, 0.8, divided by the square root of p, which is 0.8, times q, which is 1 minus p, so 0.2, divided by n, which is 98. And so if I did this correctly, we should get our z statistics negative 1.1112. Just round it to 2 places. Negative 1.11. Okay, so to get our p-value, what we're going to do is, we'll work it over here, we'll look at our null distribution, which is a z distribution. If it's a z-test, you want to look at a z distribution. If it's a t-test, use a t. If it's a chi-square test, use a chi-square. We'll look at a z-curve or z-distribution, and let's locate our test statistic. So maybe it's right here. This is negative 1.11. Okay? And our p-value is just the chances, if the null hypothesis is true, it's the chances of getting a test statistic at least as unusual as the one we've got. So if we're testing whether it's smaller than 0.8, we would want everything to the left of it. So if it's a left-tailed test based on this, your p-value would be everything to the left of it. If it was a right-tailed test, meaning this is a greater than, you'd do everything to the right of it. If it was not equals, it'd be a two-tailed test, and what you would want to do is just find the smaller one and double it, essentially. So if this was a two-tailed test, we just take this area right here and double that area. So to find this area, you could use your z-table. I calculated in the calculator using something that might be a little bit more exact. So this p-value says 0.1332. If you use the z-table, the amount of area to the left of negative 1.11, 1335. So if you use the table, 0.05. If you use, StatCrunch or a computer type of package to do the whole thing, you'd get 1332. So pretty close. What about our decision? Remember, what we do, what we want to do to make our decision is this. It's based exclusively on that p-value. Alpha sets the threshold. Okay, the book told us to use alpha be 0.05. And what we do is, if our evidence is conclusive, meaning this test statistic is fairly rare, like it doesn't happen very often. If it's an unusual test statistic, we'll reject. So if your test statistic, if your p-value is less than alpha, your decision is reject. If your p-value is greater than alpha, you fail to reject. Okay? And so if we take a look at our p-value, either one you use, 1335 or 1332, those are obviously bigger than 0.05. So our decision would be fail to reject. Okay? So we'd say we fail to reject H0 and can't conclude that, now you write the alternative, that p is less than 0.8. So it means we don't have enough evidence at the 5% level to say that p is less than 0.8. So if your p-value you would have calculated over here would have been less than 0.05, then you would have said we do reject the null and we can conclude that p is less than 0.8. So you can exchange the fail to reject for reject and the can't for can, and then just write out your alternative. All right, so that's it.